Hi everyone. So today we'll be talking about the other type of chemical reactions. Some part of it we are already done in the first part of the type of chemical reaction, and this is in continuation to that. So this is the second part of type of chemical reaction. And today I will try to finish this complete chapter. So let's get started now. Okay, so see, activity 1.6 is again talking about a thermal decomposition reaction. You all know that thermal means heat. So this is related to heat because you know that if you remember, I've already told you all that if you're having something and you want to break it, to break will require any kind of energy. That could be heat energy, that could be electrical energy, or that could also be the light energy. So because we are using heat here, decompose means to break something, right? So if to break this, I require some kind of energy, and if that is heat, I will be calling it as thermal decomposition reaction. I hope that's clear. Now let's see this activity here. They're talking about take about 2 grams of lead nitrate. Lead is PbNO3. So we are taking PbNO3 powder in a boiling tube. You can see there is a test tube. In that we've added this PbNO3, and now we are heating it with the help of the Bunsen burner. So when you will heat it, the things that you're going to get is a PbO plus NO2 plus O2. So this is what we're going to get. So this is a thermal decomposition reaction because one reactant is giving us 3 products. So that's a decomposition, breaking of things, right? Now, the color of this gas evolved is brown. So how will you remember that what is the color of the gas? You can remember it in this way, no to brownie. And NO2 is the gas evolved and the color is brown, no to brownie. Okay, I hope that's clear. Now hold the test tube with a pair of tongs and heat it over the flame. What do you observe? We have observed evolution of nitrogen gas, the formation of lead oxide. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide, and the reaction taking place is this. I hope that's clear to you all. Now let's see the reaction. It is the same one as we already discussed, right? Now activity 1.7 we can discuss. Now activity 1.7 is again a decomposition reaction. This time we'll be talking about electrical decomposition, and whenever we are using electricity for the decomposition, that is called as electrolysis. So this is the word lysis means breaking. Okay, so we will be using electricity to break the components from which the water is made. That is electrolysis. Okay, so you can see we're using 2 glass tubes inside which we have the graphite rod. Why we're taking graphite rods? Because graphite rod can easily allow the passage of electrons from one side to the another side. That means electricity is transported, right? And that is the reason we are using it. So electricity is provided from here, right? And then we are having these 2 electrodes so that the electrons flow can be there. And moreover, I can say electricity flow can be there. We're having the water. We're having this, and by using this electricity, it is going to break into H2 plus O2, right? But as I'm seeing this equation, it's not balanced. So to balance this equation, I have to put a 2 here. And now I have to put a 2 here. Now you all can see, when I was taking H2O, I'm getting 2 volumes of hydrogen and 1 volume of oxygen. So this is a very, very important point here, that hydrogen gas is produced in more amount and oxygen gas is produced in less. Okay. So for electrolysis cell, because in this we are having one container inside which you are having both the electrode dip. So this type of solution is called as electrolysis. This electrolysis is happening in the electrolytic cell. So this is an electrolytic cell, okay? And for electrolytic cell, you all have to remember this. POW NCR. This is a trick. Positive anode oxidation. That means on anode, which gas is going to go? Because anode is positive. So on this, a gas oxygen, because oxygen generally carries a negative charge. Here it is O2 is 0, but otherwise oxygen carries a negative charge. So you can learn it in this way, that oxygen will go on the anode side. And if we talk about the cathode, cathode carries a negative charge, and that is the reason the hydrogen gas will be collected here on this. So this is what is there in this activity. I hope it's clear to you all. And if you still find any kind of issue, you can write it in the chat box, or my mail ID is also mentioned there. And I will also tell you my mail ID at the end of this session. You can mail me also if you have any doubt. Now, another kind of decomposition reaction that we are going to study. Now, you all can see we're using the sunlight. Sunlight we're using, that means H nu, we can write this, right? So in this china dish, we were having silver chloride, right? And the silver chloride we were having, and now with the use of sunlight, this AgCl is now breaking. Earlier it was only one reaction, and now it is broken down into two things. This is silver and chlorine gas, right? So this is a decomposition reaction related to sunlight. That means it is a photolysis, you can say. Photo means light, right? So this is a photolysis reaction, you can say. Okay, let's move to the next part. Okay, now another one is this silver bromide reaction will also be same. We are having AgBr using the sunlight, we're getting Ag, and bromine to gas will be given at. Always remember bromine is also brown. Okay, Br, the symbol for bromine gas is this, Br and Br, brown. Okay, so the above reaction is used in black and white photography. This all of you should remember that it is used in black and white photography. Okay. Now, let's see another part of this. Okay, let's do another one, which is, now we are taking about 2 grams of barium hydroxide in a test tube. Barium is Ba and hydroxide is OH. So we are taking this in a test tube now, and to this we are adding ammonium chloride. We are adding this to it. Okay. Now mix with the help of a glass rod. Now touch the bottom of the test tube with your palm. What do you feel? So is this an exothermic or endothermic reaction? This you all have to do. Because you've done all type of reaction, this reaction you all have to do by yourself. Just try to do it. If you will not be able to do it, I will help you with this. But just try to tell me the product of this reaction, and also tell me if it is from outside, if it is cool, the test tube will be cooler, or it is hot. Okay, this you all have to tell. Otherwise, we will do the in-text question, and that time I will help you with this. Now, let's do another kind of reaction, that is a displacement reaction. For this, first you all should be aware of the reactivity series, which is, I'll tell you all that. Just learn this line. Please stop calling me a zebra. Instead, try learning how copper saves gold. I hope that's clear to you all. And now from this, the trick is there. For P, it is potassium. For P, it is potassium. The symbol is K. Okay. My God, what am I doing? Now, next, S is for sodium. And the symbol for this is Na. For Ca, it is calcium. And the symbol is Ca. M is for magnesium. That is Mg. A is for aluminium, which is Al. And Z is for zinc, which is Zn. I is for iron, which is Fe. T is for tin, which is Sn. L is for lead, that is Pb. H is for hydrogen. H is for hydrogen. And copper, again, Cu. S is for silver. And G is for gold. Symbol for silver is Ag. For gold, it is Au. So I hope this is clear to you all. So the elements, the metals which are at the top, they are more reactive than the one present beneath them. So please remember this. And based upon this, you can do the question now. See, this is the displacement reaction. Displacement means here is we are going to play with the power. So let's say if I am sitting on this chair, and if somebody else want to come and sit on this chair, that means that person should be more powerful than me, because that person first has to replace me from my position, and then only that person can take my position, right? So if already a powerful person is sitting on this position and a less powerful person come and try to take my position, that will not be possible, right? But yes, if a more powerful person comes and try to take my position, then I will be displaced from my position, right? In the same way, if we talk about these elements like potassium and sodium, you all know that potassium is at the top. So potassium is the most powerful one, right? So if let's say sodium is there and now potassium want to take the position of sodium, so it can easily do, right? But let's say zinc want to take the position of sodium, so that is not possible because sodium is very powerful than what zinc is. In the same way, like in this question, you all can see iron nail is there, that means Fe. And copper sulfate solution is there, which is CuSO4. The color of CuSO4 solution is, this is blue, okay? Now, let's see which one is more powerful. Is copper is more powerful or Fe is more powerful? Let's see this. Okay, see, this is iron. And where is copper? Copper is here. That means zinc, this iron is more powerful than this copper, right? Because see, it is at the top. Iron is at the top and copper is coming after 2-3 elements beneath this, right? So that means this can easily replace copper from its position. So it can become FeSO4 plus copper. So this is a displacement reaction. That means now the color of this solution is also going to change, and not just the solution, this iron nail color will also become different because now this Fe is getting dissolved in the solution, and that is how the solution color is changing. And because now from this copper sulfate, this copper is now becoming into solid, it is going to get collected over the iron nail also. Okay, I hope that's clear to you all. And now let's see the next part, what all is written here. As we've already discussed, this is the iron nail color, and now you all can see iron nail taken out from the copper sulfate solution. This is how it is looking now, and this was the copper sulfate solution, right, earlier. And when the reaction is taken place, see, the color has changed. So why does the iron nail become brownish in color? Because now it is coated with the copper metal, and you all know that the color of copper metal is brown, right? And the blue color of the copper sulfate is also fading because now iron is present there, right? Because Fe is present there. That is the reason why the color is now changing. And the color will change to blue-green. It will look a bit blue-green in color. Okay, so this is the reaction that is taking place there. And the another reactions which are written here are also similar to the one that we discussed. Like zinc is more powerful than copper. So zinc can easily displace copper from its position. It will become ZnSO4 and copper. Okay. And again, Pb is there, CuCl2 is there. So Pb is more powerful than copper. That is how it has become lead chloride. I hope that's clear to you all. This is all about displacement reaction, and you can also call it as a single displacement reaction, because the displacement is taking place only one time, right? Only one time. Now, we'll be talking about the double displacement reaction. By the name itself, it is very, very clear that displacement is going to take place 2 times, right? So here, 2 things will be there. Let's see. You can see earlier we were having in this test tube, we are having barium chloride, right? And from the another test tube, we are now adding sodium sulfate. Now, what is sodium sulfate? Sodium sulfate is this, right? So this Na will be 2 times. Okay. Now, again, we're using is BaCl2 because that is barium chloride. So now, because both the things are going to react, so you can see Na is replaced by this Ba, and it will give you NaCl. That means one displacement has taken place here, right? And let me change the color so that you all can understand. And the another displacement is of this, once Na has taken the position of this Ba, right? And once Ba will take the position of Na, right, to make this. So this is a double displacement reaction. So when the displacement is happening 2 times, it is called double displacement reaction. And not just this, all the double displacement reactions will be precipitation reactions. So what caused this type of reaction? The white precipitate of BaSO4 will be formed. Always remember, the color of BaSO4 precipitate formed is white, right? It's formed by the reaction between these ions. Okay. So this was a double displacement reaction. Now, another one. Next part is Recall activity 1.2, where you will find those. Okay, we are having now lead nitrate. Lead nitrate is PbNO3 2 times. And with this, we're adding potassium iodide, that is Ki. So what is going to happen? The product that you'll get is PbI2 plus KNO3. Just balance it. Put the 2 here and that's it. Okay. So this is again a double displacement reaction, because once this Pb is taking the position of K, that is potassium, and now the potassium is going to take the position of Pb, right? So that's a double displacement reaction. Now this PbI2 will give yellow color PPT formed. So it is also a precipitation type reaction. Okay. I hope that's clear to you all. Now next is oxidation and reduction. You should be aware what is oxidation. Oxidation is addition of oxygen, okay? And the reverse of this is reduction, that is removal of oxygen, okay? And now, again, oxidation is removal of hydrogen. Now, opposite to that will be reduction. You will be adding now addition of hydrogen. And not just in terms of hydrogen and oxygen you can write, you can also talk in terms of electrons, right? So oxidation is loss of electron. That means you're donating the electron to the other one. So we are using the electrons, that is oxidation, and reduction is gain of electron. Gain of electron, okay? So on this concept, we will be now talking more about this oxidation and reduction. Now let's see. See, we're having a Bunsen burner. By using that, and on the tripod stand, we have taken a china dish in which we have poured this copper powder. You all can see this copper powder is brown in color, right? Now, the surface of copper powder become coated with the black copper oxide. Why? Because you're heating the copper powder in presence of the oxygen, because oxygen is around there. So because copper you're heating, in presence of oxygen, it will become CuO, that is copper oxide. And the color of this copper oxide is black. Why has this thin substance formed? Why? Because oxygen was there, it has now reacted with it, right? So this is because oxygen is added to copper and copper oxide is formed. So if hydrogen gas is passed again, now let's say I want to reverse this process. Whatever has happened, now copper oxide has become, I want to reverse this process. So if you want to reverse this process, for that you have to add hydrogen gas to this. So let's do that. We'll be now adding the hydrogen gas to this, and it will give us again, write it here, copper and H2O. That means you will again get your copper back and the color will be again changed. I hope that's clear to you all. So if hydrogen gas is passed over the heated material, that is copper oxide, the black coating on the surface turns brown and the reverse reaction is taken place. And that is how we are again getting our copper back. Okay. Now, let's discuss one more thing. As I've already told you, same thing is written here in your books now. If a substance gains oxygen, not able to see the proper line. Yeah. Now, if a substance gains oxygen during a reaction, it is said to be oxidized, right? Gaining of oxygen is oxidation. And if a substance loses the oxygen, that is reduction, okay? Now, during this reaction, copper oxide is losing the oxygen. Can you all see? This is copper oxide, and now it is becoming only copper. That means this copper, which is on the reactant side, which is copper oxide, is now becoming copper. That is reduction, because it is losing the one oxygen atom. And because this hydrogen atom is gaining one electron on the product side, this is the oxidation. I hope that's clear to you all. What is oxidation and what is reduction? Now let's see one more example. See, ZnO is there. That means zinc oxide is there, and it is now going to zinc. That means it is reduction. Now if you see carbon, carbon is now becoming carbon monoxide. So that is oxidation. In the same way, another reaction is there. You can see this is MnO2 and it is now losing the oxygen to become this. And here you all can see hydrogen is gaining one oxygen. So it is again oxidation, right? So I hope that's also clear to you all. Same thing is written here. Now, see, in the reaction 1.31, carbon is oxidized to CO and ZnO is reduced to Zn, right? And HCl is oxidized to Cl2 whereas MnO2 is reduced to MnCl2 in the another part of the reaction. Okay, now we'll be talking about what is corrosion and rancidity. Okay, corrosion is the rusting. Like, okay, some of you might not be even aware that there's a difference between rusting and corrosion. Rusting is when we only talk about in terms of iron, and whenever you're talking about any other metal, we always say corrosion and not rancidity is for the eatable items, rusting is for iron, and corrosion is for all the other metals. Okay, so we have observed that iron articles are shiny when new, but get corroded with a reddish brown powder when left over for some time. This process is known as rusting. See, they're specially mentioning for iron, they're saying rusting, and for other, we will be using the corrosion. Like you might have seen with silver, if you keep it in open surface for some time, it gets a black coat over it. That is because of the silver sulfide layer over it. And if we talk about copper also, copper gets a coat of copper carbonate over it, and not just this, of quick lime also. Okay, slate lime is also there on that layer which is formed outside of the copper, which gives it a green color. So this is the reason why copper get green coat around it. So now when a metal is attacked by substance around it, such as moisture, acid, it is said to be corroded, and this process is known as corrosion. So the black coating of silver and the green coating of copper are some example of the corrosion, right? So corrosion causes danger. It's a very dangerous thing because see, we are investing into so many things, like we are making the bridges, and many big industries are there where iron articles are used, where other metal articles are used, right? So corrosion on a whole is creating a very big loss there. So we try to adopt other method like painting the metals by galvanizing them. This is going to help us to reduce our losses, right? And now if we move to rancidity, rancidity is same like corrosion, and you can say this rancid, what was it, that rusting, yes. But rancidity is in terms of eatable things. When they are getting oxidized, that is rancidity. So have you ever tasted or smelled the fat and oil containing food left for some time open? Because their taste changes because the oxygen which was present outside has now come in contact with the food. It's a very slow process, and it is going to degrade the quality because it has now got oxidized, right? They become rancid and their smell and taste changes. Usually substances which prevent oxidation, that is the antioxidants, are added to the food containing fats and oil, keeping food in airtight container. That's the reason we always prefer to put them in an airtight container, or we put them in the fridge, so that this oxidation process can be it should be submerged a little, so that its effect is not very pronounced, right? So yeah, this is it for today. I hope this chapter is, I think, done also, and it is also clear to you, right? And now I'll be uploading one more video for all the in-text question, and maybe 2 parts of the video will be more there for the back questions. One video will be there for all the in-text question, and 2 videos will be for all your NCERT questions, and 5-minute videos, as they're already coming, they will come now also. I hope you all are learning something from my videos and they are helpful for you all. So please make sure that you all like, subscribe to my channel, and you all can comment down whatever doubts you're having. And my mail ID is mail.silkyyadav@gmail.com. Anytime, any doubt you're having from chemistry chapters, you can mail me, and as I will read them, I will surely reply back to your mails, or you can type your question in the chat box also. So yeah, this is it for today. I hope you all have enjoyed today's session. Now we'll be meeting some another day with some another great session with your in-text question or your NCERT question. Till then, take care. Bye-bye, all of you.